Now we will see the checksum. Let's start the session with the outcomes. In today's session, we are going to learn and understand the checksum and its performance. And we know very well that the third error detection mechanism that we are addressing is the checksum. Let's start the session with what is a checksum. The name itself says that checksum means it is going to check the sum. So the sender is going to create the message, and with the message it is going to calculate the checksum and it is going to attach the checksum to the message. How this checksum is going to be created and how it is going to be validated, that we are going to address in today's lecture. So obviously, in the sender side the checksum is created and in the receiver side the checksum is validated. So after validation, if the receiver finds out that there are no errors, then the packet is accepted or the data is accepted. Otherwise, the data is rejected. Let's see how this checksum is created in the sender side. The operation of creating the checksum in the sender side involves 4 steps. Step number 1. Break the original message into k number of blocks with n bits in each blocks. For example, if we have 20 bits and we want 4 blocks, so we will have 20 bits in 4 blocks where 5 bits in each block. That is what this point is all about. So breaking the original message into k number of blocks where in each block we have n bits. And step number 2 is we are going to sum all the k data blocks. We know in the previous step we have broken the original message into k number of blocks and we are going to add or sum all the k number of blocks. The summation sometimes may generate a carry, and add the carry to the sum if any such carry is generated. And the last step is just to do one's complement to the sum. Whatever we get after performing the one's complement, that is called as the checksum. So the checksum will also be of n bits. Every block of data is of n bits and the checksum will also be of n bits. So basically the operation at the sender side involves 4 steps and we have seen all the 4 steps in points. Now let's look at the operation diagrammatically. The original data is broken into k number of blocks or sections where each block is of n bits. This is step number 1. And in step number 2 we are going to sum all the sections, that is all the n bits. After adding all the blocks we will get n bits only as the sum. In case if it generates a carry, just add that carry to the sum and we will again get n bits only. After getting n bits, just do one's complement and whatever we get after performing one's complement is the checksum. We know that this checksum will also be of n bits. And we know this is the original message and this is what the checksum that we have created. Now all the bits or all the sections are sent to the receiver. At the last we will be appending the checksum. We know this is section 1, section 2 up to k sections. This is section 1, section 2 up to k sections, and finally we are appending the checksum. And what the receiver does? Very simple. The receiver collects all the sections and it also collects the checksum and just performs the sum or the addition. If the result of the addition is if it is all ones, the receiver accepts it. Otherwise, it rejects the data packet it has received because there are transmission errors. Let's understand the checksum's operation with an example. Let's consider the data unit to be transmitted is this one. Now we know step number 1 is breaking the message into blocks. So we are breaking this original message into 4 blocks, 1, 2, 3, 4, and each block has 8 bits. Up to this is block 1, up to this is block 2, here is block 3 and here is block 4. Now let's see what the sender does. We know the sender only has created these 4 blocks. The sender places all the 4 blocks in order to perform the addition. Just see, this is block 1, this is block 2, this is block 3 and this is block 4. And what the sender does? The sender have to perform the addition. So the sender is now performing the binary addition. 0 plus 1 is 1. So no carry is generated. The result is 1 and no carry. And here 0, 0, 1, 0. The addition is 1 and no carry. 1 plus 1 is 1, 0. It's binary addition. 1 plus 1 is 1, 0. 1, 0 plus 0 is 1, 0. And 1, 0 plus 0 is 1, 0. So here we get 0 and a carry as 1. So 0. And we take that 1 to the next column. This 1 is the carry here. Now just add this carry to this column. Now we will get 1 0. So 0 we are placing here and 1 as the carry here. Now just add 1 plus 1 is 1 0. So we are placing 0 here and 1 as the carry. 1 plus 1 plus 1 is 1 1. So 1 here and 1 as the carry. 1 plus 1 is 1 0. So 0 here and 1 as the carry. 1 plus 1 plus 1 plus 1 is 1 double 0. So 0 here and 1 0 is the actual carry. And we know that if we get a carry, that has to be wrapped around. It means that has to be added to the sum what we have got. So just bring this 1 0 here. So what I am doing? Just bringing this 1 0 to the result. Again you perform the addition operation. So 1 0 is 1. 1 1 is 1 0. So 0 here and 1 here. We have 1 here and that 1 is brought here and the other things are kept unchanged. Now we got the summation with carry. After we do the sum, we are required to do the ones complement. Now let's perform the ones complement. Ones complement means changing ones to zeros and zeros to ones. So in this case, this 1 is becoming 0, this 0 is becoming 1, 1 is becoming 0, 0 is becoming 1, and we are performing the ones complement. After we perform the ones complement, whatever we have is the checksum value. Now we got the checksum. What the sender does? This is the checksum. This checksum value is appended with the message. Now if you notice here, this is the actual message and the checksum is appended with the message. Now this is sent to the receiver. What the sender does? It creates the checksum. With the data block, it appends the checksum. Now this value is sent to the receiver. So sender part is over because sender for the message, it has created the checksum. Now it is the responsibility of the receiver to know whether there are errors or not. Now comes the receiver's turn. What receiver does? It collects all the data blocks including the checksum and the receiver sums all the data blocks and the checksum, and if the result is all ones, it accepts. Otherwise, it rejects. Let's see it with the same example. This is what the data block that the sender has sent. Let's assume that the receiver is receiving the same data block without errors. Now the receiver is receiving everything and this is the checksum. And if you notice here, this is the checksum. And all these data blocks are just placed here in order to perform the addition. Now to perform the addition, just do binary addition and we get the result. Here 1, no carry. Here 1 plus 1 is 1 0, so 0 here and the carry is 1. 1 1 1 is 1 1, so 1 here and carry 1. 1 1, again 1 1, again 1 1, again 1 1. The binary addition of 1 plus 1 plus 1 plus 1 plus 1 is 1 0 1. So we are going to place 1 here and the carry is 1 0. We know that if any carry is generated, we have to wrap it around. So 1 0 is brought, again the addition is performed, and now you can notice the addition. And if we get the result as all ones, the receiver accepts it. Because the result is all ones and the receiver understands that there are no transmission errors. That's it about the checksum. Let's now analyze the performance of checksum. Basically, this checksum is a very powerful technique because it can detect all errors involving odd number of bits as well as it can detect most errors involving an even number of bits. So it is powerful to some extent in detecting bit errors as well as burst errors. But the main problem is, if one or more bits of a segment are damaged and the corresponding bit or bits of the opposite value in the second segment are also damaged, then the sum of these columns will not change. If the sum of the columns are not changed, the receiver will not detect the errors. Simply, if the errors involving that there is no change in the summation, then the checksum technique will not detect the errors. That's the drawback. And that's it, guys. So far we have seen how to generate the checksum value in the sender side and how the checksum is validated in the receiver side. I hope you guys have enjoyed the session and thank you for watching.